This screencast is about correlation. So as we've been discussing, there are four kinds of things that you can do with results in quantitative research. Last week we talked about descriptive statistics and different ways of describing the numbers that you get. This screencast will be talking about correlation, or a way of looking at the relationships between between two different variables. Later on, we'll talk about comparison, looking at different ways of comparing groups or results across groups. And finally, we'll look at prediction, or a way of using statistics to anticipate what might happen if you changed one variable. But for right now, we'll just talk about correlation. So correlation measures the association or relationship between two continuous variables. And that continuous variables part is important. As you remember, a continuous variable is sometimes also called an interval variable. It's a variable where all the potential options go in an order, and there's the same amount of space or the same interval in between different answers. So for example, first grade, second grade, third grade. Correlation, however, does not measure causation. And it's important to distinguish the kind of common use of saying, oh yeah, those two things are correlated, they're related, from what we mean when we use correlation as a statistical test. It has a very precise definition when we're talking about correlation as a statistical test. As you remember, for there to be causation, for us to say that one thing is causing another thing, not only do the two variables need to be correlated, we need to have removed all confounding factors, and we need to have established a time relationship, which came first. So this test we're about to talk about, correlation, does not do that for you. It does not measure causation. And for correlation to make sense, you need some kind of logic or rationale or a theory. So we can do correlations often misused, and we can find there are a lot of existing correlations. For example, there's a correlation between the number of drownings in pools every summer and the number of Nicolas Cage movies released in the previous year. So they have a statistical correlation, but they don't have a factual correlation. Another example is someone did out the math, and there is a statistical correlation between the number of pirates sailing the seas and global warming. So as there are fewer pirates, our average sea temperature has gotten higher. Again, this is a statistical correlation. It's been shown with numbers, but it's not a factual correlation. We really can't say that the reason for global warming is because our pirate community has grown smaller. So having a logic or theory or rationale for why you're exploring the statistical correlation between two variables is important. Otherwise, you end up with a lot of interesting but meaningless data, like the thing about Nicolas Cage movies or pirates and global warming. So there are four kinds of correlation. The first one is no correlation. So there's no correlation between number of therapy visits a child gets and their ultimate score on a test measuring social isolation. That's no correlation. There can be what's called a positive correlation, which means that the two variables move in the same direction. So when the dependent variable increases, the independent variable increases. So the older I get, the independent variable, the more gray hairs I have, the dependent variable. A negative correlation, the dependent variable decreases when the independent variable increases. So in other words, the two variables are moving in different directions. This can also be called an inverse correlation. So for example, the older I get, the independent variable, the less I can remember the dependent variable. The final kind of correlation, which we see less, is called curvilinear correlation, which means that the two variables move together until we get to a critical cutoff point. at which point the relationship between the variables changes. So, for example, a really good example is my happiness level and my cousin crashing on my couch. So, in this example, my happiness level is the dependent variable, and the number of days my cousin has slept on my couch is the independent variable. And this is a curvilinear correlation because the first, 3 days or so that my cousin's staying with me, my happiness level increases. So as the number of days my cousin's with me increase, my happiness level increases. Then, though, about 4 days, he starts getting kind of annoying. He drinks all my alcohol, he doesn't clean up, he sleeps in really late, he doesn't shower, so my happiness level starts, at that point, at that critical point of 4 days, my happiness level starts decreasing as the number of days my cousin has spent on my couch increases. And that's a curvilinear correlation. You see curvilinear correlations much less frequently. It's more common to see a positive correlation or a negative correlation. So this is an example of a positive correlation. So the longer I work in an agency, the higher my burnout score is. So the two variables are moving in the same direction. This is also a positive correlation. As my caseload decreases, my burnout score also decreases. And even though the two variables are decreasing, it's a positive correlation because they're moving in the same direction. So the positive or negative relates to whether or not the variables are moving together, not whether they're increasing or decreasing. So a negative correlation would be, for example, the higher my score is on a job satisfaction scale, the lower my score is on a burnout scale. So the variables are moving in two different directions. So the more hours I spend with my dog, the less I want to spend time with people. So those two variables are moving in opposite directions and are an inverse or negative correlation. So to interpret correlation tests, you get what's called an R-score. And an R-score is always a number between -1 and 1. And this number is the R-score, this number between 0 and 1, is always about the strength of the relationship. So it's not telling you what your score is on the burnout scale. It's not telling you the actual number of days that your cousin has been sleeping on your couch. It's talking only about the relationship between the two variables. And the closer the R score is to 1, the higher or the stronger the correlation. So 0.9 is a very high correlation. 0.5 to 0.7 is generally considered a moderate correlation. And 0 to 0.3 is considered, 0 is no correlation at all, and up to 0.3 is considered a low or not so meaningful correlation. 0.3 to 0.5 is considered a low correlation. So again, this is looking at the strength of the relationship between the two variables and doesn't speak to what the variables themselves actually are. So the first thing you look at when you are doing a correlation test is you'll get this number between -1 and 1, or from 0 to 1, that tells you how strong the correlation is. And again, the closer to 1 it is, the stronger the relationship. Next, you'll notice that R score, this number here, has either a negative sign in front of it or a positive sign in front of it. If it has a positive sign in front of it, it's a positive correlation. And if it has a negative sign in front of it, it's a negative correlation. So, for example, if your R score was -0.7, that would mean there was a strong or high negative correlation. And if your R score is 0.7, that would show you that there is a high or strong positive correlation. I'm not going to go over the math of how correlation is calculated, how that R-score is calculated. You can look that up on your own time or take a statistics course. We're not going into it here. All you need to know is look at whether how close the number is, the R-score is to 1, and whether it's negative or positive. So this is just another way of looking at how to interpret that R-score. So again, if the R-score is 0, there's no correlation. If there's a positive sign, if the R-score is positive, the two variables increase or decrease together. So they move together and it's a positive correlation. It's very rare to see a perfect correlation. So you'll much more often see an R-score of 0.9999. If there's a perfect correlation, it may mean something, some errors were made in the math. And again, a negative or inverse correlation is when the variables move separate from each other. So as one increases, the other decreases. And a negative correlation is shown with an R-score that has a negative sign in front, or negative number. In addition to your R-score, when you calculate a correlation, you'll also get a p-value. And p-values are used across all different kinds of statistics, and they're a mathematical way of saying how probable it is that the relationship between the two variables, in other words, that the R-score you got, is not just due to chance alone. So statistical significance is concerned with measuring the uncertainty of life. There's a lot of uncertainty in coincidence. So it could be that you're getting a score, an R-score, that says two variables are closely related. Statistical significance looks at, are these variables appearing to be related due to chance alone? Or is something other than random chance at play here? If something's statistically significant, it means that it's likely not due to chance alone, so it's not just a coincidence. We're not really going to go into the math of p-values very much. The magic number you need to know is 0.05. Once you have a p-value of 0.05 or less, you can assume that the R-score you got is statistically significant, that it's not due to chance alone. If your p-value is higher than 0.05, that means it could just be a coincidence. So if it's 0.06 or 0.7, it's likely that the R-score you got is just a coincidence. It's just due to chance alone. So you want to see statistical significance, which means a p-value of 0.05.